All the stoichiometric calculations we discussed so far assumes a very basic assumption, which is the reaction goes with 100% completion, 100% conversion of the moles of reactants transform to moles of products. This is not always the case. For example, when you try to make some popcorn, for example, if you start with 100 kernels, you will notice that what you get usually is not 100% popping of them into popcorn. As you can see in this example here, you get like 82 and you find that you have 18 remaining that did not transform. The theoretical yield of this conversion from kernel to popcorn would have been 100% if the 100 kernels completely popped to 100 popcorns. But what actually you obtain is called the actual yield of your process, and in this case it's 82. And to emphasize this fact, we calculate the percentage of the process as a ratio between what you obtain to what you would have obtained if the process has been 100% successful. So it would have been what you obtained compared to the ideal amount you could have obtained times 100. That's the percentage of the percent yield, which is 82%. Similarly, in chemistry, for any reaction, we define a percent yield, which is a ratio between the ideal maximum obtainable yield and the actual amount that you obtained from a reaction. So the ratio between these two quantities is the percent yield of the reaction. So you calculate it by dividing the grams you actually obtained from the reaction to maximum grams obtainable. Let's do this example to understand the concept of percent yield. Titanium is a very hard and light metal that is used in building aircrafts and spacecrafts because of its toughness and light weight as well. And in industry, we obtain titanium by converting a titanium compound like titanium tetrachloride in a reduction reaction with magnesium to get the titanium metal and magnesium chloride. So if you start with this amount of titanium tetrachloride and we react it with this amount of magnesium, what would have been the theoretical yield of titanium in grams? And again, theoretical yield is assuming that the reaction proceeds by 100% success. Second question is, what would be the percent yield if you actually obtain this amount of titanium out of the reaction? So the first step is determining the theoretical yield, and for this step you have to calculate the maximum amount obtainable of titanium based on the number of moles of limiting reagent. So you have to compare the two reactants that you have and use the one that is the limiting reactant to calculate the maximum amount of titanium you could have obtained. So you take grams of titanium chloride and convert grams to moles, and then moles to moles of titanium. So the first conversion is gonna require the molar mass of titanium tetrachloride. So you take grams and multiply it times molar mass. And the second conversion is gonna use the mole to mole ratio from the chemical equation in the previous slide, which is 1:1. Carrying out this calculation should give you that number of moles of titanium, again, if the reaction would have proceeded to consume the whole amount of titanium chloride. And you repeat the same thing with magnesium. Again, you convert grams of magnesium to moles of magnesium to moles of titanium obtained if magnesium is completely consumed. So you take grams of magnesium, multiply it times the molar mass, that's the first conversion from grams to moles, and then moles of magnesium to moles of titanium is going to be obtained using the mole to mole ratio from the equation, which is 1 to 2, and that should give you that number of moles. And then you compare the two numbers of moles of titanium based on both of the reactants, and the smaller one is going to be the limiting reagent. So it's obvious that the number of moles of titanium obtained from titanium chloride is smaller than what is obtained from magnesium, which means titanium chloride is the limiting reagent. It's going to run out first, and it's going to limit the maximum amount of titanium we could have obtained. So that is the maximum amount of titanium that you could obtain out of this mixture of reactants. And then you simply convert moles to grams using the molar mass of titanium, and that gives you that maximum amount of titanium from this mixture of a reaction. So what we just calculated here is the theoretical yield, the maximum obtainable amount of titanium from this mixture of the reaction. The actual yield was given in the problem itself to be this quantity right here. So you calculate the percent yield of the reaction by dividing the two quantities, and that gives you 88.4%. So just to check, your percent yield should always be less than 100%. So another example here, another chemical of industrial importance is nitroglycerin, which is a powerful explosive. And this is the decomposition reaction of nitroglycerin. It decomposes to produce a bunch of gases, which expands significantly and causes the destruction or the explosion that takes place in this case, which becomes even more significant with the heat that causes the expansion to be even more significant. So we want to calculate the percent yield of grams of oxygen that could be obtained from 200 grams of nitroglycerin, and calculate the percent yield if what you actually obtain was 6.55 grams of oxygen. In this case, we already know the limiting reagent, which is the original compound, nitroglycerin, so we don't need to do the comparison step. We just use the grams of nitroglycerin, convert them to moles of nitroglycerin using the molar mass as a conversion factor, and then take the number of moles of nitroglycerin and convert them to moles of oxygen using the mole to mole ratio from the equation, which is 1 to 4. And then take these moles of oxygen and convert them to grams of oxygen using the molar mass of oxygen, and that gives you 7.05 grams of oxygen. And the second problem solution is just dividing the actual yield that was given in the equation in the problem, which is 6.55, divided by the maximum obtainable amount of oxygen, which is 7.05 grams, times 100, and that gives you 92.9% completion or conversion of the reaction.